Hello everybody, I'm David Coates, and today I'm going to show you how to run a Lego using C# code. So what do we have? The first step is a super awesome Lego. This was a birthday gift to myself back in February, and while it was a lot of fun to build, it's even more fun to drive. It's remote control. Here's the remote controller, and here are the receivers, infrared transmitters, infrared receivers. And from the remote control, we can drive it forwards, backwards, we can make it dump its bucket, tilt its bucket, lift its front end loader up and down, lift the bucket, and we can even turn it. So we can drive it around using the Lego remote control, but that's a bit of a manual process. Maybe we can automate it. So that's the dream. What are the steps here? Well, we have a laptop. It's got some C# code here. We'll talk about that in a sec. The laptop is connected to the Netduino. Here's a Netduino Plus 2. The Netduino has various pins for circuit output. So here is the wiring of an infrared LED. So what do we have? The infrared LED is the equivalent of the infrared LED on the controller. The Netduino runs the .NET micro framework, and this Netduino can be programmed via this laptop, via C#. So I downloaded a excellent library from GitHub, the Lego Power Functions library. It contains code for working with the SPI interface of the Netduino and outputting various voltages at a certain carrier frequency, which happens to be 80 kilohertz for basically all infrared devices, whether it's a TV remote, Lego. So that code does most of the work, and all I had to do is wrap it in a little program. So this program has three parts that we'll see at work. We have an Is It On LED section. That's just to test that the Netduino is hooked up and working. This is important because we can't actually see the infrared LED work. We then we use the Lego Power Functions code, very simple. We create a transmitter, we create a receiver, and we create two motor objects that correspond to various motors in the Lego. We're then going to set these motor speeds, and then we're going to brake. Very simple, just make it do something. Let's see it work. So let's compile and run it. As you can see, it's doing a bunch of work. The Netduino is being rebooted. The Netduino has assemblies deployed to it, and suddenly we're in a debugging session. You can see the yellow, that's our current line. At the moment, the Netduino LED is off, no light. When you turn it on, poof, bright blue. So it looks like, yes, as we step through, our code is working, the Netduino is running. Now the LED is off. We're going to set up our transmitter, our receiver, our two motors, and then here's where the magic happens. So let's set the motor speed to 90% on both these motors and watch what happens. So here goes the small motor. See how the bucket is tipping? Here goes the large motor driving forward, and then let's stop. That's it.